In this Ethers Crash Course, you'll learn everything you need to know to interact with the Ethereum blockchain using a JavaScript library called Ethers.js. You'll learn how to use Ethers.js to connect your MetaMask to your decentralized application. We'll read data from smart contract on the blockchain. We'll transfer Ether from one to another account. We'll deploy contract on the blockchain. We'll listen to emitted events from a smart contract. So if you like content like this one, make sure you subscribe to this YouTube channel and let's get started. So let's start by creating our decentralized application, and for this I'm going to just create a index.html file, and in here there are basically two ways to import Ethers.js into your project. You can install Ethers.js as an npm package by saying npm install and Ethers.js, but since this is not an npm project, I'll import Ethers.js through a CDN, which I can do like this, and I'll write all the functions for this project inside index.js file, which I'll reference using this. Then I'll create a button which will just say connect, and this will call a function connect MetaMask that I'll define here. I'll then create another button, get balance button. This button will call my get balance function. So let's save this for now and go into our Ethers.js, and then create a provider. So once you import Ethers.js into your app, you have access to the Ethers object, and I'm using the Ethers object to get a provider, and I'm initializing this provider from the window.ethereum object that I get that is injected from MetaMask. Then I'll create a signer variable. This variable is used to sign transactions. I'll create my connect MetaMask function, and by connecting your MetaMask to your decentralized application, you get access to the account, the transaction history, and a bunch of other stuff. So here I'll use the provider to call send function and pass the ETH request accounts parameter, and then I can get my signer, and I can with the get signer function and assign this to the signer variable, and then I'll just print out the account's address by calling the get address function. Then create the get balance function. In here just call get balance onto the signer, and this we await this call. This returns a promise, so we save this inside balance, and we print out this balance here and just divide by 10 to the power of 18 because this is in way. So let's save this now, and you can run this code by just installing an extension called live server, and just once you have this installed, right click on the live server. This will open an app on the localhost on the port on this port, and now I have the connect and get balance function. And if you were to pull up the console log and print out Ethers, you're going to see in the console, of course, you're going to see that we have the Ethers object. So just print out Ethers, and this is the Ethers object that we get and that we are using. So if I now click on connect, I get printed out my address, and if I print out get balance, I get 1.2 Ether because that's how much Ether I have in my account, as you can see here. Let's now see how you can read data from a smart contract, and let's see the contract. The contract that we're going to read data from is deployed on the Kovan testnet. So if I go up here, this is the contract we are going to read data from. This is the address that it was deployed to. If we go into this contract section, you can see it's verified. That means we can see the source code. This is the source code, and we'll just read stuff like the number of decimals, etc. And let's go now into Visual Studio Code and add a button. Let's call this read data from smart contract. This will call the read data from smart contract function. So let's create that. And you need three things to talk to any smart contract in Ethers.js, or just two in general. The first is the contract address. The second one being the contract ABI, which you can get if we go into the browser. You can see the contract ABI here into the contract section. And the third thing is the provider that actually we already have. So this is the contract address. I just copied this from the Kovan. This is deployed on Kovan testnet. So I just copied this address from here. Then we need the ABI, and you can copy the ABI from here, but there's a lot of things you don't need. And by the way, for those of you that didn't know, ABI is just the contract representation or in JSON format. I prefer to write the ABI, I think this is called in a human readable format, where this is just an array, a string array, and you just provide the function signature here, or as I like to call them, function definitions. So you only put here the functions you're going to call. So we're going to call the name function of this smart contract, and I believe you can see all the function if you just search for the name. As you can see here, this is what we're going to read, and we're also going to read the symbol. And here we just provide the function signature, and we have the contract address, so it means we can call this function. So let's create the read data from smart contract function. I'll create a contract instance from using the contract constructor, and then I'll just pass in the address, ABI, and the provider. We have the provider initialized here. Then I'll just call the name function, and I can do this because I have provided the name function signature up here in the ABI. I'm doing the same thing for the symbol, decimals, total supply, and I'm also going to check out my balance, the balance that I have in this USDT contract. And for you to get some USDT in this contract, you can go to the Aave faucet and just this is just testnet USDT that you get from just on the Kovan testnet. And to get some USDT, you have to select Aave version 1, then press on submit. This is going to give us 10,000 USDT. This is just fake USDT on the Kovan testnet, as you can see. And make sure your account has selected the Kovan testnet. And this is pending, and once it's complete we should have 10,000. And once the transaction is confirmed, if I go to my MetaMask, click on assets, and up here I should have USDT. So I have 28,000 USDT, and if you're not seeing your token here, just go up here, copy the contract address, click on import tokens, and just import your token. To see my balance, I'm just calling the balance of function on the USDT contract, and here I'm just printing out the name, symbol, decimals, and when I'm printing the total supply, I'm dividing by 10 to the power of 6, because as you will see later when we print the decimals, this USDT contract has 6 decimals. And the same applies for the balance. So let's now go into my browser, run this in your browser, and if I click on read data from smart contract, I should get the name, which is USDT coin, the symbol, the decimals, the total supply, and it's not only 3 coins, but it's this large number, and my balance is 28,000. And notice here we didn't need to get the signer because this is we are only reading data. So now that we have some USDT in our accounts, let's see how you can transfer this USDT to another account. So if I open MetaMask here, you can see I have 28,000 USDT on this account, in my first account, and in my second one I have 2,000 USDT. So let's try to send some USDT from my first account to my second account. So let's go into Visual Studio Code. I'll create another button here, send USDT to account. This is calling the function with the same name, and in my index.js I'll create that function. Again, create an instance of this contract, and all I need to do to send the USDT is to access the contract, of course, then click on then connect the signer, because we are changing the state of the blockchain. We need to connect a signer, then call the transfer function, provide the person that you want to transfer to, and then the amount you want to transfer. I think this is $500, and I'm providing this value in a way. Way is the smallest unit of measurement in Ether, and I'm saying I'm adding 6 more decimals because that's how much decimals this USDT contract has. So let's save this, go into my browser, and for this transaction it's important that we get the signer. So for that, click on connect. Now we have the signer variable, then we can call send USDT. Now MetaMask is asking me if you want to send $500 from account 1 to account 2, and after the transaction is mined, if I go to asset on my first account, you can see I have $500 less, and if I go to my second account, I have $500 more. Let's see how you can deploy contract now on the Kovan testnet. So this is the contract I want to deploy. It just stores a number variable. It has an increment number function that just increments the number by 1. And we have some other ones that I'll explain later, but for now let's go into Visual Studio Code, add another button. This is the deploy contract button, and here in the index.js I want to create the deploy contract function. Then I'll need the ABI from the contract. You will see how you can get this from Remix. We also need the contract bytecode, and this is basically Solidity is a compiled language, and to basically you don't put Solidity into on the blockchain, but you only put the bytecode, you only deploy the bytecode. So when you get Solidity, you compile this into bytecode, and this is what goes to the blockchain. And I'll create a factory contract from the ABI and the bytecode, and I also need the signer. Then I'll call the deploy function. This will deploy my number contract, and then we'll wait for the transaction to be completed. And this deploy transaction is just the transaction that deploys the contract. And if I call wait for this on this transaction, this will create a transaction receipt, and this basically when this finishes, we are sure that the transaction was mined on the blockchain, and I'll just print out the transaction receipt. And how can you get the ABI and the bytecode? So if I go into a Remix and I go into this compiler section, you have the ABI here. So just click on the ABI and I'll say equal to, and just paste this here. So that's the ABI. Let's see how you can get the bytecode. So go up here, we have the bytecode right next to the ABI, and then if I just paste the bytecode here, you can see this is an object and it has multiple keys and value pairs. So the one we need is this one. This is the bytecode. It's just a long string of characters and numbers. So just copy this, remove all the junk here, and we want to say equal to an empty string and just paste in the bytecode. So now we're ready to deploy. Go into the Brave browser. I want to get the signer here by clicking connect. We have the signer, and now we can deploy contract. I'm doing this on the Kovan testnet, so click on confirm. To check out the deployed contract, go just search your account on the Kovan blockchain explorer, and then go, you can see the transaction, it's made 20 seconds ago. So click on the transaction and just open that bad boy up, and you can see this is actually, if I go here, you can see this is a contract creation, and if I go to the transaction, this is the contract address. Now that we have deployed the contract, let's interact with the contract using Ethers.js. For this, I'm going to add another button. We have so many buttons now. So increment number on smart contract, and in my index.js I'm going to create this increment number on smart contract function, and here I need to provide my contract address, and we can get this from the transaction. So just click on copy here, paste this bad boy here, then just add the number contract ABI. Then I'll create an ABI, and here I want to just call a function on a smart contract, and I want to call the increment number function. Actually, let me show you the function. So if I go into Remix, this is the function I want to call. For that I need to provide the signature now, and I also have a number function because the public variable number is automatically creating a number function. Then I need to create the contract instance. Then I'll just call the number function on my number contract, save this inside variable. I'm going to print this out, and this is a big number object, so I have to call toString to get the actual number. Then what I'll do is I'll use the signer. I'll connect the signer to the contract and call increment number. This should increment number from 1 to 2. And for this I'm getting a transaction response object, and this is the object that has all the properties of the transaction. And then I'll call the wait function on my transaction response, and this will, what we'll do is we'll wait for the transaction to be mined on the blockchain, and we need to make sure that the transaction was added to a block and to the blockchain before we check if the number was incremented. So now I'm calling again the number function, and here I'm printing out the number, which should be 2. Let's see if this is correct. If I go into my Brave browser, into my app, and I need to get the signer for this one because we're changing the state. Click on connect, then click on increment number. It looks like I have incremented the number before, so let's MetaMask will ask me now to if I want to increment it again. We'll wait for the transaction to be mined, and we should get 3 now, and there we go. Let's now see how you can emit an event and read the emitted event immediately using Ethers.js. So for this I'm going to add an emit an event button with a function that gets triggered when you with the same name, and in the index.js I'll create this function. I'll use the exact same address for my number contract that I've used here. In the ABI I'm just going to add this emit an event function that we have implemented in our contract. So if I go into my contract, you can see the emit an event function. This function just emits an event. I'll create my contract like so, and then I'll just connect the signer, then call this emit an event function that we defined in the ABI. From this I will get the transaction response, and I want to call the wait function on the transaction response to wait for this transaction to be mined, and then I get the transaction receipt, and I can call and I can print out the events array with this one, with the first element, to get my event. So let's try this in action. Go into your browser, into your decentralized application, and for this we need a signer, which means we have to connect. Let's just read the balance so everything's good, and click on emit event, confirm the transaction. And by the way, make sure you have your MetaMask pointed to the right network. This contract was deployed to the Kovan testnet, and you want to point your MetaMask to Kovan. You want to choose Kovan on MetaMask, and because otherwise this would not work. And as you can see, the event was emitted. We got this event now, and if I open this object up, you can see topics here, and these are just the values that were emitted. This is my address that was being emitted. So if I go to my contract, you can see we're emitting the address and a number 99. So if I go back, this is my address and this is the number 99, but this is in hexadecimal format. So if I copy this, go to this converter, paste this in, and if I convert this, you're going to see that this is 99. In this example, what we did was emitted an event and immediately just printed the event out. But what if we want to sort of set up an event listener, and it just sort of listens for events being emitted in the background? So let's create a listen to events button for this. Go to the index.js. Here we want to create this listen to events function, and for this example I have deployed another contract, actually the same contract, and this is why this contract has a different address. Then I'll just have this ABI here that I got from Remix, create the number contract object, and then to basically create a listener on this contract, you have to access the contract, then say on, and then the name of your event. In my case it was called my event. This is the name of the event that was specified in the contract, and once this event is emitted, this callback function will be called with these parameters that are emitted in the event, and we'll just print this out. So this is the contract I have deployed, and to emit an event I'm just going to interact with this emit an event function, then confirm the transaction. Actually, before we emit an event, let's just go ahead and click on this listen to events to set up this event handler. And after you've set up your event listener, if you were to emit an event like I did and go back into the console, this will trigger the event listener and it will print out the from and the number that was. Another thing that's very common that you'd want to do in Ethers is when you call a transaction, you want to send some ether into the transaction and into the function, into the payable function. And for this I'm going to create this button, send ether, when calling function, and in my index.js I'll create this function, provide the address for the contract I have just deployed in my previous function, create the contract instance here, and whenever you send a transaction you can provide options, and here I'll just create an object. This option is basically an object, it has a value, and I'll just send 0.005 ether into the transaction. Just access my contract, connect the signer, call the deposit function, and just pass the options here. We'll then wait for this transaction to be mined. We'll get the balance from the contract by just calling this getBalance function, and we'll print it out. Let's see if this works. So click on connect, then send ether when calling function. MetaMask will now ask you if you want to send 0.005 ether into this transaction. So if we print the balance and make the transaction, you can see the balance of the account is now this much ether. This is represented in way, and this way is exactly this much ether, and it's a little more than I've sent. That's because I already had this much ether in the contract before I send the transaction. And that's all I have for you today. If you like content like this one, make sure you subscribe here, and until next time, peace out.